Okay, troops. Just check and see I got the right mic turned on. Looks like I forgot the camera. It's not the end of the world. Anyway, so getting this spreadsheet ready, just make it easier to understand, and you can use this in the during class period. So it should be at least one person in each group that's brought along their laptop. Now there's a table too. Like I made up these data taking tables. Oh, no, that's not it. But anyways, I'll be bringing them along to class. Blah blah blah. Where'd it go? Oh, isn't that interesting? I must have saved it somewhere else. But anyways, oh, goodness gracious. Okay. Well, I'll have to find them. I made up, let's see, I'll show you a couple things. Yeah, I started trying to recreate the table, like the larger table at the end of the manual, and it was really difficult, but for the very least we need to get, when you take data, you'll be taking the time and the position, just wherever you measure the position of the timers, and then the rest is all analysis. Excuse me. So the first thing we're going to do is you got to try to level the track, and then you do that by sort of there's, yeah, why don't I get the pictures I made? So there is at either end, or maybe only at one end, there's a sort of thumb screw, and you can adjust up the end a little bit, and you basically sort of put the sled in the middle, and you kind of tweak this thing until the sled doesn't go anywhere. The interesting thing is that the friction is so low that little breezes in the room will cause the sled to move. So the final way you check and see if you got it right is to get it as level as you can, and then you send the sled first from the left to the right, and then from the right to the left, and you measure the you've already written down the positions of the gates. And these are just, when you get into class, you have to find out what these numbers are. And then you run it through. And I actually haven't done this one, but I'm guessing is the first one triggers all of them. And each one will measure a time as the sled goes by. So when this thing starts going, it hits this one, and they all start counting. And then this shuts that one off, then it shuts this one off, and so on. So then it tells you from t equals 0 to t1 to t2, and then you just write them down. Now, there's some chance that this won't be 0, but this will still work with it, however we set this up. Okay, so we need some more columns. So we're going to need what's called T average, and I'm going to explain what that is, and that's in seconds. Then we need, let's get fancy here. We need a insert Greek letter, Greek and Coptic. And we need a delta, alpha, beta, where is, here we go, alpha, beta, gamma, delta, A, B, well, it's not a C, D, sigma is an E. Anyways, we're going to insert a delta, and that's going to be delta T, which of course is in seconds, and then we need a, same thing, we need to insert it again, delta S. We're using S for distance, and that's going to be in centimeters. Then, oops. And then we need the velocity. Let's see, that's in meters per second. And let's think about this. I think that's it. And so first we need is this t average. So let's see what that is. And what we have to keep in mind is that, oh, I'm going to turn my tablet on. So that, well, keep in mind, this might be new for you. So what we've done is our data is a bunch of times and positions, right? And so we put t on this axis. Well, we're going to call this t1, I suppose, because we're going to, well, we don't know. T0 might not be 0, but it doesn't matter right now. The important thing is that we're going to have a bunch of t's and then some points, and we expect that as the time goes on, the distance increases, right? So what we're going to do is, since speed what strictly speaking, average speed is delta s over delta t. What we're going to do is, if you've even, we're going to use something that's sort of like the trapezoid rule, say, if you've ever taken calculus. And what it said, what we're going to do is we're going to do this little kludge. So notice that this thing here looks kind of like a curve, right? So we have a t1, say t2. Let's call this t initial, t final, and then we have x initial and x final. Now this might be a curve, but we're going to assume that the distances between these two dots are such that we're going to calculate an average velocity. And if you think about it, the distance, so if we wanted to think of, give me a minute, I'm going to pause this. So if I'm multiplying, right, sorry, oops, here's where I got it, S equals, I still got to pause again. Okay, now remember. What we're going to do is we're going to assume the difference, these delta x, or I said s, we're going to assume that the delta s and the delta t's are small enough, and just think of this. It's the same thing as when people thought the Earth was flat, right? If you're on a ball, if you see a sphere, and we're looking from far away, but as you get closer and closer to it, you're getting a smaller and smaller piece of it. If you get close enough, it looks like a straight line, right? So we're saying that even if this might be a curved shape, we're going to say that the average velocity at some time t, and what we're going to do is we're going to pick it to be right there in the middle. And if we do that, that means that if we take t final plus t initial and divide by 2, so let's say this is 1 and that is 2, that's going to be 3 over 2, and that equals 1.5, right? So we're going to say this is the time, And then we're going to pick, and we're going to say at that time, even though in this, you might realize because this is curves, velocity is changing, we're just going to say that the average velocity is at the point right here. And then we're going to say this is also the instantaneous velocity. And in calculus, then you would have it like this. And, we can go over these things if you're really confused. Hopefully your lecture professor has done a whole build-up of this to you. So again, we're going to use the average time as the middle of the time interval, and we're just going to assume within the interval that the velocity is basically constant. So even a curved line, if you move if you keep these time slices small enough, then it's not a bad correction, unless if you got a really radically curved line and you try to do a straight line. But for the most part, that's not going to be true for us. Okay, so I want to get rid of all this if I can. Let's see. No, I want this lasso select. There we go. All right, so I got to turn off the tablet. So one thing you may notice that we're going to, even though we have, say, a certain number of points, we're going to end up with one less. So let's go over here. So the first thing is to get the average. So that's going to equal, and in fact, we could use, we can use the average function. Why not? And we want the average of these two guys. So it's only the average over the pair. T average, if you like, per pair. So those are the pairs. Just happen to be intervals between each one of the timers. So we can then grab this, and so we end up with basically the halfway point. Now what we need is the delta t per pair. So that's going to equal the, where did it go? Something's, my drawing tab was turned off. Why is my keyboard not working? All right, something's up. I'm going to pause for a minute. All right, I don't know what I did, but one thing I forgot is that, you see, I downloaded Lab for Analysis Starter. I need to save it with my name in it. Lab for Analysis. There we go. Let's see. So now, spreadsheet. Yeah, so I'll just put my own name there instead of Dr. Harry. Make sure you do, well, yeah, you should be, just in case. I mean, Canvas, if you have to upload it, Canvas generally will tell me, but you should just get in the habit. Okay, so we need the delta equals, so it's the pair, so it's this time minus the one before it. So, oops, oh yeah, I put a parentheses in there somehow. So now I fill those in. And next step is the size of the intervals. So again, per pair. So that equals this distance minus that distance. And how do I keep getting? Thought the tablet's off. Oh, I'm gonna move the tablet out of the way. I don't know what's going on here. We got ghosts in the machine. All right. You want to accept? Yes. So in this case, they're all going to be 10 centimeters. And now we want the speed, or well, now we're going to, this is actually the average velocity per pair, but we're also, remember, we're also going to use it as the instantaneous. So we have the delta S divided by the delta T, and that's going to be, and I put it's centimeters per second. Oh, and don't forget, you type, well, no, you guys already have this done. You don't have to do the formatting. Never mind. Okay, so now we have ourselves a bunch of velocities. So now we can make a plot. Now here's a new trick. I don't know if we've done this. You hold down the control key, and we want to select T average and speed. See, while we're holding down the control key, in fact, it kept this one. We don't want that one. So don't hold down. First select that one. Now hold the control key down and select that. And then we want to insert a chart. And we want no lines. And let's check. So